Since the dawn of humanity, the question of whether we are alone in the universe has intrigued and inspired countless generations of scientists, philosophers, and dreamers. The discovery of new planets, moons, and galaxies has only amplified this curiosity, fueling an ever-growing quest to answer one of mankind's oldest questions: are we the only ones here? Among the many celestial bodies discovered in recent years, one in particular stands out for its proximity to Earth and the tantalizing possibility that it might harbor life. That planet is Proxima B, a rocky exoplanet orbiting the star Proxima Centauri, located just 4.2 light-years from Earth. Since its discovery in 2016, Proxima B has captured the attention of the scientific community and the public, as it is the closest known planet to Earth that might potentially support life. With the arrival of advanced space telescopes like the James Webb Space Telescope, JWST, we now have powerful tools to peer into the distant reaches of space and explore the mysteries of planets like Proxima B. The excitement surrounding Proxima B stems not only from its proximity to Earth but also from its location in the habitable zone of its parent star. The habitable zone, often called the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist on the surface of a planet, critical for life as we know it. The mere fact that Proxima B is located within this zone suggests that it might possess some of the key ingredients for life. However, being in the habitable zone does not automatically make a planet habitable. There are a multitude of factors, such as the planet's atmosphere, the type of radiation it receives, and its geological activity, that could determine whether life could ever take hold. Proxima B is often described as an Earth-like planet. This designation, however, does not necessarily mean that it resembles Earth in all ways. The term Earth-like refers to its size and composition, which are similar to Earth's. Proxima B has a mass that is about 1.7 times that of Earth, which places it in the category of rocky planets, those with solid surfaces as opposed to gas giants like Jupiter or Saturn. Its surface is likely made up of similar materials to Earth, such as iron, silicates, and metals. However, Earth-like does not mean that the planet has oceans, forests, or breathable air. The conditions on Proxima B may be far more extreme than anything we experience on Earth. One of the key features of Proxima B is its close proximity to its host star, Proxima Centauri. This star is a red dwarf, a type of star much smaller and cooler than our Sun. In fact, Proxima Centauri has only about 12% of the mass of the Sun, and it emits much less energy. For Proxima B to maintain temperatures that could support liquid water, it needs to orbit very closely to its star. Proxima B completes one orbit around Proxima Centauri in just over 11 Earth days, much shorter than Earth's 365-day orbit around the Sun. In other words, Proxima B is much closer to its star than Earth is to the Sun. The average distance between Proxima B and Proxima Centauri is only about 7 million kilometers, compared to the Earth-Sun distance of about 150 million kilometers. This extreme closeness to its star means that Proxima B receives far more radiation than Earth does, which could present challenges to the possibility of life. Despite its proximity to its star, however, Proxima B is not always exposed to the harsh heat and radiation. It is likely tidally locked, meaning that one side of the planet always faces the star while the other side remains in perpetual darkness. This tidal locking happens because Proxima B is so close to its star that the gravitational forces between the two bodies have caused the planet to rotate in sync with its orbit. As a result, one hemisphere of the planet experiences constant daylight, while the other remains in eternal night. This leads to a stark contrast between the day and night sides of the planet, with the day side potentially being scorchingly hot, while the night side is likely freezing cold. However, the region between the day and night sides, often referred to as the twilight zone, could offer conditions suitable for life. In this narrow strip, temperatures might be moderate enough for liquid water to exist. The day side of Proxima B could be hot enough to melt ice and snow, sending water vapor into the air. On the night side, glaciers could form, and in the twilight zone, the combination of melting ice and moderate temperatures might create an environment conducive to liquid water. In fact, simulations of the planet's climate suggest that the twilight zone could harbor conditions that are not unlike the cooler regions of Earth, potentially allowing for the existence of lakes, rivers, and even oceans. But what about the atmospheric conditions on Proxima B? For life to exist, the planet would need a stable atmosphere capable of retaining heat and moisture. Without an atmosphere, the planet would be unable to maintain the necessary conditions for liquid water, and any potential life would be doomed. The atmosphere would also need to provide protection from harmful radiation, especially since Proxima Centauri, being a red dwarf, is known for its flares and bursts of ultraviolet radiation. These flares are much stronger and more frequent than those of our Sun, and they could potentially strip away the atmosphere of any planet in close proximity. This intense radiation could prevent the development of life, as it could destroy the planet's water and make the environment too hostile for any organisms to survive. One of the key factors that could determine whether Proxima B can retain its atmosphere is the presence of a magnetic field. On Earth, our planet's magnetic field plays a crucial role in protecting our atmosphere from the solar wind, which is a stream of charged particles emitted by the Sun. If Proxima B has a similar magnetic field, it might be able to shield its atmosphere from the damaging radiation emitted by its parent star. Some scientists even speculate that Proxima B may have once been located further from Proxima Centauri, in a more stable region of the star system, before being pulled inward by gravitational forces. If this is the case, Proxima B could have retained more of its original water, and perhaps even developed a more Earth-like atmosphere in the distant past. Despite these possibilities, the question remains, could Proxima B support life? The short answer is that we don't know yet. There are many unknowns about the planet's atmosphere, its climate, and the amount of radiation it receives from its parent star. In 2017, a team of scientists conducted simulations to determine whether Proxima B could maintain liquid water, and their results were promising. They found that it might be possible for liquid water to exist on the planet, particularly in the twilight zone, where temperatures could be moderate enough to allow for the presence of lakes and rivers. However, these simulations were based on a number of assumptions, and much more data is needed to confirm the planet's potential habitability. One of the most exciting developments in the search for life on Proxima B is the role of the James Webb Space Telescope, JWST. Launched in December 2021, the JWST is the most powerful space telescope ever built, with the ability to observe distant planets and stars in unprecedented detail. The JWST's advanced instruments are designed to study the atmospheres of exoplanets and search for signs of habitability, including the presence of water vapor, oxygen, and other key chemicals that could indicate the potential for life. Proxima B is one of the prime targets for the JWST, as its proximity to Earth and its position in the habitable zone make it an ideal candidate for investigation. In addition to studying the planet itself, the JWST is also helping scientists search for signs of alien civilizations. In 2020, astronomers detected a potential radio signal from the Proxima Centauri system, which was initially suspected of being a message from an extraterrestrial civilization. The signal, known as BLC-1, was quickly analyzed and found to be of terrestrial origin, caused by the distortion of Earth-based radio signals. While this particular signal did not provide evidence of alien life, it did spark renewed interest in the possibility of finding intelligent life elsewhere in the universe. The search for extraterrestrial intelligence, SETI, continues, with the JWST playing a key role in exploring this exciting frontier. While Proxima B's potential for harboring life is still uncertain, the search for answers is just beginning. With powerful telescopes like the JWST and advancements in space exploration technology, we are closer than ever to understanding the true nature of this enigmatic planet. Will Proxima B prove to be the Earth 2.0 we've been searching for? Only time will tell. But as we continue to explore the stars and study the planets that surround us, the dream of discovering life beyond our own world remains a tantalizing possibility, one that might just be a little closer than we ever imagined.